inside 3ds Max, you can always design and work with quadropolygons. The software will provide you with full support for convenient polygons modeling. However, once you try to import a quadropolygon's geometry, that might be quite challenging for 3ds Max or any other 3D software in general. During this series, I have mentioned, in more than one place, the importance of converting your project into triangles once you have completed it. We are now in a very advanced stage, and our project is almost complete. Out of importance, let's summarize the proper method of preparing your project or assets for exportation. Hello and welcome to this tutorial. The method I usually use in transferring or sharing assets between different projects is through the OBJ file format. By using this method, we can guarantee no connection, link, or dependency between different projects. However, I do prefer using the FBX file format when exporting the entire project for other applications or sending it to other users. Due to the importance of the FBX file format, we will extend the explanation for the FBX Exporter options. In order to fully answer the question of how to avoid the FBX UV map or texture misalignment, we need to dive into a very important topic, which is the regulations for proper exportation from 3ds Max. First, make sure that all the scene assets are in triangles. Although we can let the exporter's plugin to triangulate all the exported scene, I do prefer to perform this process of triangulation inside 3ds Max. Select the quadro assets, then add Turn to Poly modifier. Limit the polygon size value to 3. As you might notice, some edges are not oriented correctly. We need to manually correct those edges and keep them symmetrical on the y-axis. Hide the Turn to Poly modifier, then, on the sub-object level, insert an edge with the desired orientation. Collapse the Turn to Poly modifiers. If we let the plugin do the triangulation process of the geometry, we shall not have any control over this process. To be precise, we shall not have any control over the inserted edges orientation. This is why I strongly recommend to do the triangulation process inside 3ds Max. The second rule of the regulations is the pivot point location. Select all the scene assets, then switch to the pivot menu. Once you hit Effect Pivot Only, the pivot handler, or gizmo, should appear in the viewport. The location of the pivot point of all objects must be at the center of the world. If not, switch to the Move tool, then zero the values of X, Y, and Z axes. Make sure the gizmo is oriented correctly to the world axis. The gizmo information are stored in the object level. Any manipulation of the object location or orientation at the object level will affect the pivot point information. From the Pivot menu, press Reset Transform to correct the pivot orientation. Switch to the Move tool, and zero the values of X, Y, and Z axes to reset the pivot location to the world center. Manipulating any object at the sub-object level will not affect the pivot point information, such as location or orientation. The third rule of the regulations is reset xform. Scaling, moving, and rotating, all these transformation processes, information, are stored in the object. To ensure proper exportation, we need to reset the current state of the scene assets back to origin. And to do so, we need to use reset xform to reset those transformation values back to the origin state. We are simply telling the software, this is the new origin state of the 3D object. You can add the xform modifier from the modifiers list. This will work fine when a single object is being selected. However, for group selection, the modifier will reset the whole group, which is not what we actually want. We need to reset each object individually. To do so, within a group selection, we have to use Reset Xform from the Utilities tools. Press twice on Reset Selected button. In the past, I occasionally found that adding two Reset Xform modifiers are required to do the reset correctly. Since then, it became the default habit to reset the Xform. Select all the scene objects, then add Edit Poly modifier. Collapse the Edit Poly modifier. This will also collapse other modifiers in the stack to editable poly. This is the fourth and the final rule of the regulations, which is to export the scene assets in either editable poly or editable mesh. You need to collapse any modifiers in the stack before the exportation. Not all modifiers inside 3ds Max are compatible with other software. Neither the export plugins can export all the 3ds Max modifiers. We have prepared the required scene assets for exportation. Now, let's export the selection to FBX and OBJ file format. This time, we will do the exportation to include both textures and maps. Due to the importance of the FBX, we will extend the explanation of the FBX Exporter in this part of our tutorial. Under the geometry, enable smoothing groups. Most of the time, you do want to export your assets with smoothing groups. Unless you are exporting collisions, in this case, you do not need any smoothing groups over the 3D surfaces. The split per-vertex normals, you can activate this option in order to split geometry vertex normals based on edge continuity. For a better demonstration, let's explain what this option do with the help of this illustrative image. A simple plane surface is always the perfect surface when it comes to render. However, when we start bending this plane surface to create curves or corners, we will also create a tension at those curves or corners that need to be relieved. In real life, all objects' edges or corners are often chamfered, unless they are intentionally needed to be sharpened, as in scissors, blades, knives, and swords. During the designing stage, we can relieve this tension by chamfering those edges to mimic real-life objects. However, we cannot use chamfering to mimic real-life edges or corners in every object we design for the game industry. Especially when we consider the count of the added polygons that cannot be avoided when using chamfering. From another point of view, during the modeling for the game industry, one cannot have a surface with multiple smoothing groups without detaching them into elements for the sake of both performance and optimization. Due to the connection between the smoothing groups and splitting objects by vertices and normals, both practically are detaching surfaces based on sharpness. We cannot discuss any of these two concepts separately. Rather than that, we need to discuss them together, with a hope that this might clear the surface for you to see what's beneath. There are two methods to view or render an object. One of them is the smoothed view, the other is the faceted view. This is the look of a smoothed box or cube when a single smoothing group is applied to the whole object. However, even with the ability to assign more than one smoothing group to the box's sides inside 3ds Max, in order for the exporter plug-in to preserve those smoothing groups, it had to split or detach the box's sides based on the used smoothing groups. For a primitive shape, such as a box, the split by vertices normals will work fine. However, for complex geometries, we need to have a control over this detaching or splitting process. This is why we dedicated a complete chapter for detaching objects into elements based upon the smoothing groups. The link will be in the description. The second method to maintain sharp edges is by exporting or rendering the geometry without smoothing groups. If we exported the box without its smoothing groups, it will look faceted without detaching its sides or splitting its vertices and normals. I always use this method when exporting the created collisions from 3ds Max, as both overlapping vertices and smoothing groups are to be avoided and are not required in the collision's geometry. Whenever you need to export a primitive box to your game, you should detach its sides into elements. You cannot export the box with multiple smoothing groups without splitting vertices normals, as the exporter will apply one single smoothing group to the whole object. That will render the box with undefined edges and inaccurate shadows. Almost all the associated information with the geometry will be ruined. The green beams, or lines, emerging from the corners of the box, are representing the vertices normals. When split per vertices normals is enabled, overlapping vertices occur at the splitting intersections. This is why we got 3 beams, representing 3 overlapped vertices normals at each corner of the splintered box. Tangents, normals, and binormals are these terms that may come to your hearing when the topic is involving curve editing or splines technology. While the work environment with polygons inside 3ds Max do not offer any tools to control these terms, you do not have to worry about these factors at working or exporting assets with the polygons technology. Autodesk decided to branch the splines technology into new lines of CAD-based software, while they kept the development of the polygons technology inside 3ds Max and Maya. The spline technology remains outdated without any care or hope for updates. 3ds Max does not have sufficient tools for curve editing or splines technology. Those capabilities are under development inside separate Autodesk packages, such as Alias, Fusion 360, and Inventor. Autodesk statement is that tangents and binormals are used in advanced rendering. Since we are working with polygons, and we are not doing any advanced rendering, we do not actually need this option. The FBX can store some modifiers of 3ds Max. One of them is the Turbosmooth modifier. This is a great feature to use when exporting your assets to other 3ds Max users. Let's see how this feature works. This is a simple scene of a primitive box, tessellated by 2 iterations in the added Turbosmooth modifier. The smooth result is controlled via the smoothing groups. For demonstration purpose, I am going to export this scene into FBX file, then import it into a new scene. The imported scene still have the added Turbosmooth modifier. However, the source geometry, which was a primitive box, has been converted into editable poly. While the FBX stored the iterations number, it did not stored the smoothing result setting, which I had to reset back to smoothing groups. As we discussed early, in the regulations for exportation, we did mention not to export assets with any modifiers. The main reason for that is to avoid running into incompatibility situations with other applications. The next option is Preserve Instances. This feature works exclusively when instances clones of an object are exported. Activate this feature to preserve the instance's properties. However, when using this feature with reference clones, they will be exported as unique copies without any instance's properties. Again, this feature needs to be supported inside the targeted software. For more information about the differences between copies, instances, and references when cloning an object, check the link in the description. I am going to pass quickly on the following options. The selection sets for both objects and sub-objects can be stored in the FBX file. Storing those data will increase the exported file size. However, the tendency is to keep the file size as small as possible by excluding unwanted data. Activate Convert deforming dummies to bones to convert geometry used for deforming objects into real bones in the FBX file. The current exportation does not have any deforming geometry to be used as bones. I will leave Convert deforming dummies to bones disabled. Keep in mind, the FBX file can store any exported help dummies, even with this option disabled. Activate the Triangulate option to automatically tessellates the exported polygon's geometry. This option affects only polygons and meshes. The current exported assets are already triangulated, and I will leave this option disabled. Finally, the last option of the geometry, Preserve Edge Orientation. If you can recall our last exports from the previous tutorial, we had this option enabled. However, we did run into hidden edges orientation troubles that affect the UV map coordinates. According to Autodesk, this option should preserve the hidden edges orientation, but for some unknown reasons, it did not. Having this option enabled is the default setting for FBX Exporter. The exported editable poly will be always converted to editable mesh. Toggling this option on or off has nothing to do with it. Under Animation, you can find a lot of options that can be customized. Since we are not exporting any animation, we are going to save talking about these options for another tutorial. The same goes for cameras and lights. We do not have any of them in this exportation. The FBX file can store and embed all the associated media with the scene, or the exported assets. The FBX file can pack geometry, animation, cameras, lights, and embed media into one single file. The embedded media can be, for instance, textures, materials, and audio files. The FBX is the most reliable format when it comes to sharing or archiving the entire scene or project. These are the most featured advantages of using FBX when exporting your project or assets. When embed media is deactivated, the FBX plugin will store the relative path for textures or media associated with the exported geometry. Disabling embed media will not completely isolate the exported geometry from the associated media. When sharing assets between different projects on the same machine, you need to keep those projects unlinked to each other. Thus, I do not recommend using FBX to share assets between projects on the same machine, even with embed media activated. Activate embed media to pack the media associated with the exported assets within the exported file. The current project system unit is in centimeters. Changing the scene unit in the exporter will change the scale factor, and so the exported assets. Unless absolute necessary, you should keep the scale factor value at 1. The FBX Exporter default setting for axis conversion is Y up. When you use the Autodesk Media and Entertainment preset, the 3ds Max FBX plugin exports using the Y up axis. You can export your scene to a Z up axis if the destination application does not support the Y up world axis and cannot convert the Y up world axis of your scene. Under the FBX file format, FBX file has one of these two types, binary or ASCII. Binary is the default format for the FBX. Our main focus is on the version of FBX. You should specify the version of FBX used when sharing your exports with other users. To avoid running into incompatibility situations, I do recommend targeting old versions of FBX for the exportation. Finally, hit OK to export the selection. Let's quickly export the selection to OBJ file format. In the previous video, we talked at length about the OBJ exporter. In this exportation, I am going to disable Flip YZ axis, since we are not exporting to Poser or alike software. We will not change any other settings except for the materials options. You can customize the export options for many software. You can find them in the present drop-down menu. To export OBJ with textures, enable Export Materials and Create Materials Library file. Then you will need to specify a save location for the used textures or maps for the OBJ exporter. This is where the exporter will export textures associated with the exported OBJ file. You will have to do this every time you export OBJ with textures. Inside the Materials Export options, we are not using multiple channel maps, so I will leave the map channel value at 1. We do not have any procedural maps to render or export. I will disable this option. Convert size, format, and extend map parameters are very useful features. Maybe for some other export. Hit Export to export the selection. Once you hit Export, you will be prompted to specify the location for the associated textures of the exported assets. Press Add Search Path, then navigate to the texture location. Be aware, the exporter knows nothing about the project folder, and you need to manually locate the images folder of your project. All the newest exports for both FBX and OBJ are stored by default inside the export folder of the project, as well as the oldest exports from the previous video. Here is some interesting facts about the exported files. The exported FBX file with embed media enabled has a larger size in comparing to the old exports with embed media disabled. For the OBJ file, exported with maps, we have the geometry file, the material library file, and the maps folder. This group of selection has to be sent or moved together in order to be imported correctly without any missing maps. Next, we will import the newest FBX and OBJ files after moving them to the import folder of the targeted project. For demonstration purpose, I will import the new exports into new empty scene. Starting with the FBX file. There is nothing that we need to change in the Importer plugin options. Hit OK to import the FBX file. As expected, we did not encounter any troubles with the imported assets. Let's take a look at the imported material. The material was imported with all settings unaltered. However, during the importing of the FBX file, the Importer plugin will create FBM folder and extract all the associated media into it. Why the associated media are not automatically extracted to their absolute locations inside the project folder. Why we cannot choose the path to extract those media files. I hope Autodesk will find answers to these questions. For an exemplary course of action, we need to relocate textures to their absolute location inside the project folder. Also, we need to change the texture's location of the imported materials to absolute. Finally, let's import the OBJ file. To import textures, enable the Import Materials option. Disabling this option will import geometry without any textures or materials. The default bump, or UV channel, is channel 1. Whether you enable or disable Import Material into the Materials Editor, the importer will bring the imported materials into the Material Editor library. Enabling this option will not create instances of the imported materials inside the State Materials Editor. To edit the imported material, you need to create Material Instance by using getMaterial from Object or pickMaterial from the Materials library. Show maps in the viewport. When enabled, it will force shaded or realistic view of the imported material in the viewport. Copy maps to the project folder. The first thought that came into my mind is this option, when enabled, will link the transferred maps inside the project folder to the imported materials. Disappointingly, it does not, and the imported materials will use maps from the directory you specify. Needless to say, it's meaningless to recognize the image's absolute location by the importer and not to use it. However, one can outsmart this nonsense by moving the associated maps to their absolute location inside the project folder. Then type the absolute path for textures inside the OBJ importer, which is the images folder under the Scene Assets folder. Under Geometry, enable Flip ZY Axis. At last, but not least, under Objects, enable Import as Editable Poly. After hitting Import, you will be prompted for the location of the associated maps. Once you specify the absolute path of the maps to the importer, this data will be stored into the scene file. Afterwards, the OBJ importer will recognize and use the absolute maps location for the new imports. Another successful import, as expected. However, the surface of the imported objects looks very bright. This is due to high specular level of the material. We can lower it down from the material settings. If you might notice, the FBX file stored all the original material settings, including the specular level, which is very handy when exporting complex scenes with multiple materials of different settings. And that concludes our objectives from this chapter.